Hello students, welcome to Screencast number 5. You guys know how this works. I present to you a real-world problem, and we solve it using the techniques we have been learning in class. And then I present to you a very similar real-world problem, and you solve this one on your own and respond with a screencast, written explanation, audio recording, anything that explains your work on your own. Today's screencast is all about using formulas to solve equations, and it's all about one of my favorite topics, aviation. Alright, so let's start. The Mach number, maybe you have heard of that word before, the Mach number, the Mach of an airplane. The Mach number for an airplane is the speed of the airplane divided by the speed of sound. That is interesting. We are going to need that information. The speed of sound depends on altitude. The table shows the typical Mach numbers of several airplanes and the speed of sound at each airplane's cruising altitude. So we're talking about 3 airplanes today. The first one being the Cessna Skyhook, there's a picture right there. The second one being the Boeing 747, right there. And the third one being the Concorde. Maybe you've heard of those airplanes before, maybe you haven't. The Cessna is a civil utility 4-seat single-engine high fixed-wing aircraft originally introduced in 1956. Interestingly enough, it was built more than any other aircraft in existence. It is still to this day the most successful aircraft in existence. And it costs roughly about $307,500. The Boeing 747 was first introduced in January of 1907. It has a wingspan of 196 feet. It is a wide-body commercial airliner cargo transport aircraft. 1,500 of these have been built since January of 1970. When somebody says a jumbo jet, nowadays that's referred to any sort of large aircraft, but when it was originally said, a jumbo jet referred specifically to the Boeing 747. It's also known as the Queen of the Skies. And one of these babies will cost you roughly $352 million. And the third and final one, which probably by the picture you can tell is the fastest, is the Concorde. Originally introduced in January of 1976, the Concorde was also retired November of 2003. It is a turbojet-powered supersonic passenger or transport airliner. One of these Concordes will cost you roughly $197,918,750. So, if you have that kind of cash lying around, I highly recommend you picking up a Concorde. Surely you can probably get them on Amazon.com. Amazon seems to have everything nowadays. Anyways, let's do some math with these lovely, lovely airplanes. Anyways, we're talking about the Mach number. The Mach number, again, as for an airplane, is the speed of the airplane divided by the speed of sound. That is really, really, really interesting information to know. We're going to definitely need that to create, let's say, sort of our general formula that we're going to need for all 3 of these airplanes. Here we go. As it said, the Mach number for an airplane is the speed of the airplane divided by the speed of sound. So we know its speed of something over speed of something is going to be the Mach. All right, well, what does it say first? It says the speed of the airplane. So the numerator is going to be the speed of the airplane divided by the speed of the sound. So we know the speed of sound has to be in our numerator. Okay, that's extremely important information that we are going to use. Notice that we have created from the words, the Mach number for an airplane is the speed of the airplane divided by the speed of sound, as Mach equals speed of airplane divided by speed of sound. And that's a little bit more user-friendly to know. We are going to use an abbreviated, smaller version of this very same formula to help us solve the problem at hand. All right, so what is the problem asking us to do? Well, let's keep reading. What it says is, the table shows the typical Mach numbers of several airplanes and the speed of sound at each airplane's cruising altitude. So the Cessna Skyhawk has a Mach number at cruising altitude of 0.19 and the speed of sound at cruising altitude in miles per hour of 740. And you can see the data for the others, for the Boeing 747 and for the Concorde. We need these numbers. Why? Because it is our duty right here to find each airplane's speed at its cruising altitude by solving an equation. Round your answer to the nearest mile per hour, which means we need to round to the nearest whole number. So for example, if we get something like 23.2 miles per hour, well 23.2 of course rounds down to 23 miles per hour, the nearest whole number, no decimal. That's what we're going to do. Now, of course, these airplanes go way faster than 23 miles per hour. I mean, that goes without saying. So let's calculate how fast they actually do go. Here's the abbreviated version that I want us to use. Notice that I just abbreviated to the Mach equals airplane over sound. Now, we know full and well we're talking about the speed of the airplane divided by the speed of the sound, but abbreviating it this way is going to help us very, very much. Think of each of these words, Mach, airplane, and sound, as simply variables. They are words standing in the way of what the numbers should be. So it's up to us to replace each of those words with the numbers that we know, and the one that we don't know, well, that's the one that we're solving for. So let's begin. Let's do just that. Let's start solving for these unknown speeds. It's going to be great. It's going to be great. All right, so let's bring this over here. Let's start with the first one, the Cessna Skyhook. I think if we rearrange this bit, we might give ourselves some more room. All right, great. So the Cessna Skyhook is the first one we're solving for. Notice that the Mach number is given to us, 0.19. And the speed of sound at cruising altitude, 740, is also given to us. And that's in miles per hour, of course. Okay, so the speed of sound at cruising altitude on the Cessna Skyhawk is 740 miles per hour. That is very fast, as you know. Well, these numbers are going to be the ones that we need to use. So the Mach, can we remove the Mach and replace it with a certain number? Well, yeah, right here, it says the Mach of the Cessna Skyhook is 0.19. So let's replace that with 0.19. Now we can either replace the airplane speed or the speed of sound with one of the other numbers, and the other number is 740. Remember, these numbers down here, we'll get to those when we deal with the Boeing and the Concorde. Right now, just the Cessna Skyhawk, so just this first row. 740 is what? The speed of the airplane or the speed of sound? Well, look at the title heading. It's the speed of the sound. All we need to do is get rid of this sound and replace that with, in this case, 740, which means the airplane, remember, that represents the speed of the airplane, is what we're solving for, which, of course, is going to help us to answer the question, in which it says find each airplane's speed. All right, so let's do just that, which means the airplane speed is the unknown, so we don't have to use the word airplane every single time. All we need to do is use our variable, and we can use anything. Let's use an A to represent airplane speed. There we go. So here we have our equation. 0.19 is equal to A divided by 740, which means we have to now solve for A, the airplane speed. How do we do that? Just like we've been doing in class. Notice that the denominator is 740. A divided by 740, remember this vinculum right here means division, indicates that we have to do the opposite of what the equation is starting to tell us to do. It's telling us to divide. It is literally saying you must divide in order to solve this, but we must do the opposite in order to solve for the unknown variable. And the opposite, the inverse operation of division, of course, is multiplication. So in order to get rid of dividing by 740, we have to multiply both sides by 740. And be sure to use your parentheses. It significantly helps. And what happens to this 740 in the denominator and this 740 in the numerator? Well, as we have seen in class countless times, they simply cancel out. And remember, when they cancel out, they don't become 0, they become 1. Literally the number 1, which leaves us with 1a. But keep in mind, do we really need to use 1a? Not really. Just a is enough, because 1 times a is the same as a. But then we actually have to do the math right over here of 740 times 0.19. All right, 740 times 0.19. Let's see here. Let's do some mathematics. We get 140.6. Now keep in mind what the problem asked you to do. It said to round your answer to the nearest mile per hour, which means the nearest whole number. So 140.6, we have to look at this 0 right here and know that that 0, to be rounded accurately, is either going to go up to 1 or stay at 0. Well, what determines that? It's the digit behind it. It's this 0.6. It's the 6/10. Now this 0.6, this digit 6, of course, is 5 or higher, which means this 0 is going to jump up to the number 1. So let's move this out of the way, and let's know that 140.6 is going to be approximately 141, and let's say mph, miles per hour. Thus, we have found the speed of a Cessna Skyhawk with the given information. We know it goes 141 miles per hour. Now, that is very fast, of course. As you know, when you're in your car, you're going to go between, 20 miles per hour to anywhere to about, on the highway, 60 or even 70 miles per hour. So 141 miles per hour is very fast. What about the other two airplanes, the Boeing and the Concorde? Will those be just as fast or faster? Well, probably if you know anything about aviation, the Boeing is going to be faster and the Concorde is going to be much faster. Well, it's up to us to determine and figure out specifically how much faster. So let's do that. Let's start working with the Boeing now. Notice that the Boeing, its Mach number at cruising altitude is 0.86. Speed at sound at cruising altitude is 663 miles per hour. Alright, so that's pretty fast as well. Well, let's do something very similar. We can get rid of Mach, and this time instead of using 0.19, we notice that for the Boeing it's 0.86. The airplane's speed, well, we know that. Or do we? No, we don't know that. That's what we're solving for again. Remember, that's what the question is asking. Find the airplane's speed at its cruising altitude. Alright, but we do know the speed of sound. We know the speed of sound was 663. So once again, using very similar techniques. Remember, if you want to get rid of something that's being divided by 663, you multiply by 663. So we're going to multiply not just one side, but both sides by 663. Those two cancel out. And with a little bit of mathematics, we realize that 663 times 0.86 is 570.18 is now going to be equal to x, which of course we are going to round to, because it said to round to the nearest mile per hour, 570 miles per hour. Excellent work. So, we realize that the Cessna is 141 miles per hour, the Boeing's 570 miles per hour. What about the Concorde? Now it's time to find the Concorde, which, look at the Mach, it's much, much higher than the rest. 2.04. Incredible. Very, very high Mach number. Alright, what about the speed of sound? We also know that is going to be, in this case, 660. Notice that that's lower than what we saw for the Concorde, but we'll see if that affects the airplane's speed. And the airplane's speed is what we're trying to figure out, so we'll go back to calling that, we called it x last time, we can call it any variable we want. Let's this time call it c for Concorde. Alright, so, again, a variable could be anything, this we know. We're going to multiply both sides by 660. Multiply both sides by 660, as we have been doing in class and as we've been doing before. These 660s cancel out. And remember, when they cancel out, they don't really cancel out to become 0, because that's what we think of. No, they cancel out and become the number 1. So we're looking at 1c. But, as we remember, we just need c, which is the same as 1c. And then 660 times 2.04 is 1,346 and 4/10, which, again, round to the nearest mile per hour means this is 1,346 miles per hour. Wow, that is so much faster. The Cessna was 141, the Boeing was 570, and the Concorde is 1,346 miles per hour. So we have found all three speeds of the airplane. We are going to need these very same numbers in the part that is now up to you to solve. Here it comes. Alright, so here are the data again. It's the very same thing. But now it says to the nearest tenth of an hour. Remember, to the nearest tenth of an hour is what your answer is going to be given in. That's the first decimal place, of course. How long does it take each airplane to fly 550 miles per hour? Well, we know the Cessna is 141 miles per hour. We just calculated that no more than a few minutes ago. We know the Boeing is 570 miles per hour. We just calculated that a few minutes ago. And then most recently we saw 1,346 miles per hour is, of course, the Concorde. Now, to solve this, you're going to need a little bit more information. You are going to need the following equation. D is equal to R times T. Perhaps you've seen that before. It's a very famous equation. D, R, and T each have specific meaning. So the D, of course, is going to stand for, that's right, distance. The R is the rate. Now that's strange. What do we mean by rate? We mean speed. Yeah, exactly, because nothing more than rate is a speed. Or nothing more than speed is a rate. It's something out of something. It's a rate. In this case, it's miles per hour. And T, that's the time. but that's the time in hours, all right? Because you know time can be measured by a multitude of units. Well, in this case, in this formula, the time is in hours. So, let's see what we do know. D, R, and T. Let's put those variables off to the side. Now you're going to calculate to the nearest tenth of an hour how long does each airplane. So you're going to have three different answers. One for the Cessna, one for the Boeing, and one for the Concorde. Do we know D, the distance that we want each of these airplanes to take? Absolutely we do. It's 550 miles per hour. So in every case, all three cases, D is going to be 550. Do we know the rate? We do now. We just calculated for each of these airplanes. So it's going to change every single time. It's either going to be 141, 570, or 1,346. And the time? Well, guess what, folks? Read the question again. It says, how long does it take? In other words, you are calculating for the time using D equals RT. You know the distance, that remains the same through all three examples, all three airplanes, but the rate changes and you have to calculate the time using the proper techniques that we have been doing in class. All right, that's what you need to do. You can respond, and all the multiple ways that we have been responding before, a screencast of your own, audio recording, a written response. As long as you're explaining your work, I look forward to seeing it. All right, everyone, have a good time and good luck.